At 4:47 a.m. on March the 12th, 1943, Flight Sergeant Thomas Ridley crouched beside the starboard engine of a de Havilland Mosquito at RAF Marham in Norfolk, watching his pilot prepare for a mission that defied every principle of bomber warfare. The pilot was Flying Officer David Ashford, 26 years old, 9 operations, 0 losses. But this morning, Ashford would be flying deep into Germany in broad daylight with no fighter escort, no defensive armament, and no way to survive if the Luftwaffe caught him, except for one thing: speed. The Mosquito was supposed to be fast. 2 Rolls-Royce Merlin engines, wooden construction, lighter than anything else in the sky. The specifications said it could reach 380 miles per hour at 17,000 feet. That was fast enough to outrun most German fighters. Most, but not all. The Focke-Wulf FW-190 could hit 390 miles per hour. The Messerschmitt Bf-109G could touch 385, and those speeds assumed perfect conditions, fresh engines and clean airframes. In combat, with fuel tanks full and bomb bays loaded, Mosquitoes rarely hit their rated speed. They flew at 360, maybe 370 if you pushed them hard. That 20-mile-per-hour difference meant death. Bomber Command had lost 11 Mosquitoes in the past month, all of them caught by German fighters, all of them run down, shot down, because they couldn't quite reach the speed they needed to escape. The crews called it getting chased down. You'd see the fighter behind you, see it closing, watch the gap shrink, no matter how hard you pushed the throttles forward. And then the cannon fire would start, and you'd have seconds to decide whether to bail out or ride the aircraft into the ground. Ridley had been maintaining Mosquitoes for 14 months. He knew the Merlin engines better than he knew his own family. Twin supercharged V12s, liquid-cooled, 1,160 horsepower each. Beautiful pieces of engineering. Rolls-Royce had designed them to tolerances tighter than a Swiss watch. Every component measured to the thousandth of an inch. Every setting calibrated precisely. The fuel mixture, the boost pressure, the carburettor flow, all of it locked down by engineering specifications that came from Derby and couldn't be changed without authorization from the Air Ministry. But Ridley had noticed something that the engineers in Derby hadn't seen. The Merlin's carburettor mixture was set rich, too rich. The engines were getting more fuel than they needed for optimal combustion. Rolls-Royce had designed it that way deliberately. A rich mixture ran cooler, reduced the risk of detonation, extended engine life. For transport aircraft and trainers, that made sense. But for combat bombers flying missions where survival depended on maximum speed, that extra fuel was just dead weight burning in the cylinders without producing maximum power. The carburettor on the Merlin WWII had an adjustable mixture control, but it was locked in position at the factory. A brass safety wire ran through the adjustment screw and sealed with a lead stamp. Breaking that seal violated Air Ministry regulations. It voided the engine warranty. It could result in court-martial for unauthorized modification of aircraft systems. And if the mixture went too lean, the engine would overheat, seize, and the aircraft would fall out of the sky with 2 dead pilots who'd never know what killed them. Ridley had mentioned this to the squadron engineering officer 6 weeks ago. The officer said the mixture settings were within specifications. Rolls-Royce had tested them extensively. Changing them would risk engine failure. Besides, no ground crew had authorization to adjust factory-sealed settings. That required approval from Air Ministry Technical Branch, and Air Ministry was buried under thousands of similar requests from every squadron in Bomber Command. So Flying Officer Ashford kept flying missions at 370 miles per hour, kept watching German fighters close the gap, kept surviving by luck and skill, and the hope that the Luftwaffe would make a mistake before his luck ran out. The first crew Ridley lost was Pilot Officer James Hammond and Navigator Flying Officer Robert Chen. February 3rd, 1943. Hammond had been with the squadron for 2 months. Ridley had worked on his aircraft every morning before dawn. They talked about motorcycles. Hammond was from Birmingham, rode a Norton. Ridley had a BSA back home in Manchester. They'd planned to go riding together after the war. Hammond and Chen took off at 05:30 for a reconnaissance run over Bremen. They came back 4 hours later with the port engine smoking and bullet holes stitched across the wooden fuselage. Hammond said a FW-190 had intercepted them over the North Sea on the return leg. They'd pushed the throttles to the stops, everything the Merlins had, but the Focke-Wulf had stayed with them for 8 minutes. 8 minutes of watching tracers arc past the canopy. 8 minutes of Chen calling out range estimates while Hammond weaved and jinked and prayed. They'd escaped only because the German pilot ran out of ammunition. Hammond said if that 190 had caught them 5 miles earlier, they'd be dead. He said the Mosquito felt like it was giving everything, but it wasn't enough. The engines were screaming, the airframe was shaking, but they couldn't pull away, couldn't get that last 10 miles per hour that would have put them out of reach. Ridley looked at the bullet holes. Most had missed. A few had punched through the wooden skin, but hadn't hit anything critical. Pure luck. He'd seen what happened when luck ran out. Hammond and Chen didn't fly again. Their aircraft went to the depot for repairs. 3 weeks later, Ridley heard they'd been shot down flying a different Mosquito over Wilhelmshaven. Same story. Caught by a German fighter. Couldn't run fast enough. Both killed in the crash. The second crew was squadron leader William Morrison and flight lieutenant Thomas Parker. Morrison was a flight commander, experienced, 31, operations. He'd flown Blenheims before converting to Mosquitoes. He knew the aircraft inside out, knew how to squeeze every bit of performance from it. Parker was his navigator, young, brilliant with maps and radio equipment. On February the 18th, Morrison and Parker flew a daylight raid on a ball-bearing factory in Stuttgart. Deep penetration over 400 miles into Germany. They dropped their bombs and turned for home. Somewhere over the Black Forest, 2 Bf-109Gs intercepted them. Morrison pushed the Merlins to maximum continuous power, 3,000 RPM plus 118 pounds of boost. The Mosquito accelerated to 375 miles per hour. The Messerschmitt stayed with them. Ridley heard the radio traffic afterward, Morrison calling out his speed, Parker navigating them toward cloud cover 20 miles away. The Messerschmitts closing slowly but steadily. Morrison asking for more speed, any speed, pushing the throttles forward even though they were already at the stops. Parker's voice getting tight as the fighters closed to 800 yards, then 600, then 400. The transmission ended at 400 yards. Morrison's Mosquito went down near Pforzheim. Local resistance fighters reported the aircraft had been shot to pieces. Both crew members killed on impact. Morrison's crew chief was a corporal named Davies, a Welshman from Cardiff. Davies was convinced there was something wrong with Morrison's aircraft. He'd checked everything during the pre-flight. Engine temperatures, boost pressures, fuel mixture, everything was within spec. The aircraft was perfect. The engines had performed exactly as designed. But Morrison was dead anyway. The official report said the mission was unsuccessful due to enemy fighter interception. No mechanical issues noted. The Mosquito had performed to specifications. The problem, the report implied, was that the specifications weren't good enough. By early March, Ridley had watched 23 aircrew die. Some he'd known well. Most he'd only met during pre-flight checks, but he'd worked on all their aircraft, had signed off their maintenance logs, had watched them taxi out before dawn, watched them disappear into the grey English sky. Some came back, some didn't. The ones who came back told the same story. The Mosquito was fast, but not quite fast enough. The gap between the aircraft's maximum speed and what they actually needed was narrow, maybe 10 or 15 miles per hour. But that gap was filled with dead aircrew. Ridley started paying attention to the engine sound during run-ups. There was a specific tone the Merlins made at full power, a deep, throaty roar that rattled your chest and made the aircraft shake on its wheels. But underneath that roar, Ridley could hear something else, a slight roughness, an inconsistency in the combustion. The engines were running rich. You could smell it in the exhaust. That sweet, heavy smell of unburned aviation fuel. He mentioned this to Davies one evening after Morrison died. Davies asked what could be done about it. Ridley said, "Nothing official, but unofficially there was a way to lean out the mixture. It just required breaking the factory seal on the carburettor adjustment, and that could get them both court-martialed. The problem wasn't that RAF pilots didn't know what to do when intercepted. They knew. Every briefing covered it. Maximum speed, use clouds, head for deck and run. The tactics were clear. The problem was that maximum speed wasn't fast enough. Flying Officer David Ashford had been at RAF Marham for 3 months. 26 years old, grammar school boy from Sussex. He'd flown 9 operations and survived them all. Not because he was lucky, because he was careful and smart and followed the rules. But the rules kept putting him in situations where survival depended on factors outside his control. On his 4th operation, Ashford and his navigator, Flying Officer Michael Wright, flew a reconnaissance run over Hamburg. They photographed the dockyards from 18,000 feet, turned for home. 2 Bf-109s intercepted them over the Elbe estuary. Ashford pushed the throttles forward, watched the airspeed needle climb to 370 miles per hour. The Messerschmitts stayed with them. For 12 minutes, Ashford flew straight and level at maximum speed, while Wright called out range estimates and watched the German fighters hold position 1,200 yards behind them. Close enough to be dangerous. Far enough that they couldn't get an effective shot. A stalemate. The Messerschmitts gave up over the Dutch coast, probably low on fuel. Ashford and Wright made it home, but Ashford knew they'd been lucky. If those 109s had intercepted them 5 minutes earlier, when the Mosquito was heavier with fuel, they wouldn't have had the speed to hold the Germans off. They'd be dead. 6th operation was worse. Ashford and Wright were part of a 3-aircraft formation hitting a Gestapo headquarters in Oslo. They made the bomb run, turned for home. 4 FW-190s came up from below. The formation broke. Each Mosquito ran independently. Ashford pushed everything forward. The engine screamed. The airframe shook. The airspeed indicator showed 375 miles per hour, the fastest he'd ever flown the aircraft. The Focke-Wulf behind him was gaining, not fast but steadily. Wright called out range. 2,000 yards, then 1,800, then 1,500. Ashford weaved slightly, enough to make the Germans' deflection shot harder, but not enough to bleed speed. The Focke-Wulf kept closing. At 100 to 200 yards, it opened fire. Cannon shells arced past the canopy. Ashford watched them, watched the tracers curve through the air ahead of him, calculated that the German pilot was leading too much. The shells passed 20 feet in front. The FW-190 adjusted its aim. At 1,000 yards, Ashford dove for the deck, pushed to the nose over, built speed in the dive, levelled off at 50 feet over the North Sea. The Focke-Wulf followed. Now they were both screaming across the water at 380 miles per hour. The German was still closing. 800 yards, 700. Wright stopped, calling out range. There was nothing left to say. Then the FW-190's engine started smoking. Ashford watched it in his mirror, black smoke streaming from the cowling. The fighter slowed, fell behind, eventually turned away. Engine failure. Not Ashford's skill, not his tactics. Just luck. The German pilot had pushed his engine too hard trying to catch them, and it had given up. Ashford landed at Marham with his hands shaking and his flight suit soaked with sweat. That evening, he walked to the maintenance section, found Ridley working on his assigned Mosquito. Ashford asked if there was anything at all that could make the aircraft faster. Even 5 miles per hour would matter, even 3. Ridley looked at Ashford, saw the fear, saw a young officer who knew he was running out of luck, saw someone who was going to die if something didn't change. Ridley told Ashford to come back in the morning. He'd see what he could do. Ridley worked alone that night. The maintenance hangar was quiet after midnight. Most of the ground crew had gone to sleep. The only sounds were the distant rumble of generators and the wind rattling the corrugated metal roof. The air smelled like engine oil and dope, the fabric treatment they used on control surfaces. He opened the engine cowling on Ashford's starboard Merlin. The engine was still warm from the day's test run. In the dim light, Ridley could see the carburettor mounted on the supercharger intake. The mixture adjustment screw was on the left side, sealed with brass safety wire and a lead stamp marked with the Rolls-Royce inspection code. Ridley grabbed the screw with both hands and twisted. The safety wire held. He pulled harder. The wire cut into his palms. On the third try, the wire snapped. The lead seal fell to the hangar floor with a soft clink. The sound seemed impossibly loud in the quiet space. He grabbed a screwdriver from his tool bag, fitted it to the mixture adjustment screw. The screw was stiff, hadn't been moved since the engine left the factory. Ridley leaned into it. The screw turned a quarter rotation, then another. Each rotation leaned the mixture slightly. Less fuel, more air, higher combustion temperature, more power output. Too much and the engine would detonate. Too little and nothing would change. Ridley had calculated this carefully over the past week. The Merlin's fuel-to-air ratio at full power was approximately 0.09. That was richer than optimal. The best power mixture for most aviation engines was around 0.08. That gave maximum power before the mixture became too lean and combustion temperature spiked. He turned the adjustment screw 3 full rotations. That would lean the mixture from roughly 0.09 to approximately 0.08, a 10% reduction in fuel flow at maximum power. In theory, that should produce a 5 to 7% increase in power output. On a 1,460 horsepower engine, that was an extra 100 horsepower. On a Mosquito, that translated to roughly 8 to 12 miles per hour at maximum speed. In theory, if Ridley's calculations were correct, if the engine didn't detonate, if the exhaust gas temperature didn't spike beyond safe limits, if the pistons didn't seize, if. He moved to the port engine, repeated the process, broke the safety wire, turned the adjustment screw 3 rotations, closed the cowling. The modifications took 23 minutes total. When he finished, there was no visible evidence of the change. The cowlings looked normal, the engines looked normal. Only the broken safety wires showed anything had been done, and Ridley disposed of those in the scrap bin. He stood in the dark hangar and looked at Ashford's Mosquito. In the dim light, it looked like every other Mosquito on the flight line. But if Ridley's modifications worked, this aircraft would be faster than anything else in the squadron, maybe faster than anything the Luftwaffe could field, fast enough to keep Ashford alive. If it worked, if the engines didn't fail, if Ridley hadn't just signed Ashford's death warrant with an unauthorized modification that violated every regulation in the Air Ministry Technical Manual. Ridley walked out of the hangar at 02:30. The English night was cold and damp. Somewhere in the distance, he could hear aircraft taking off from a neighbouring base. Heavy bombers, Lancasters probably, heading for Germany. The sound made his stomach tighten. He'd just modified a combat aircraft without authorization, used calculations based on theory and guesswork. If the engines failed during flight, Ashford and Wright would die and Ridley would be responsible. But if they worked, Ashford might live. Ridley went to his bunk, didn't sleep, watched the ceiling until dawn. At 0445, he walked to the flight line, watched the ground crew fuel and arm Ashford's aircraft, watched Ashford and Wright walk out for their pre-flight briefing, watched them climb into the cockpit. At 0447, they started the engines. Ridley held his breath. The Merlins caught on the first try, coughed once, settled into a steady rumble. Normal, they sounded normal. Ashford taxied to the runway, took off at 0451. Ridley stood on the flight line and watched the Mosquito climb into the grey dawn sky. Watched it turn east toward Germany, and then all he could do was wait. The mission was a daylight raid on a Kriegsmarine communications center in Kiel, deep penetration over 400 miles into enemy territory. Ashford and Wright would be alone, unarmed except for their speed. If the Luftwaffe intercepted them, they had no defense except to run, and now they were flying an aircraft with modified engines that had never been tested, with mixture settings that violated every specification Rolls-Royce had published. The interception happened at 0647. Ashford and Wright had completed their bomb run, turned for home, climbed to 21,000 feet. They were over the Danish coast when Wright spotted them. Two FW-190s, 3,000 feet above, diving to intercept. Wright called them out. Ashford pushed the throttles forward, maximum power, 3,000 RPM plus 118 pounds of boost. The Mosquito accelerated. Ashford felt it immediately. The aircraft surged forward harder than it ever had. The airspeed needle climbed past 370, past 375, past 380. Ashford glanced at the engine gauges. Temperatures were climbing but still in the green. Oil pressure normal. Everything normal except the speed. They were doing 385 miles per hour. Ashford had never seen the needle that high. The Focke-Wulfs dove in behind them. Wright called out range. 2,000 yards, then 1,900, then 1,850. The gap was closing, but slowly, much more slowly than usual. Ashford held the throttles forward, held his altitude, flew straight and level. Watched the airspeed indicator hold steady at 385. At 1,800 yards, the Focke-Wulfs stopped gaining. They were at their maximum speed. The Mosquito was at its new maximum speed, and the Mosquito was faster. Ashford held course for 2 minutes. The range stayed constant at 1,800 yards. Then slowly it started opening. 1,850 yards, 1,900, 2,000. The FW-190s were falling behind. Wright watched them through his window, watched them shrink, watched them eventually turn away, giving up the chase. Ashford maintained maximum power for another 5 minutes, then reduced to maximum continuous. The Mosquito cruised home at 370 miles per hour. The engines ran smooth and cool. No problems, no issues. When Ashford landed at Marham at 0815, Ridley was waiting on the hard stand. Ashford shut down the engines, climbed out of the cockpit. His face was flushed, his hands steady. He walked straight to Ridley. Ashford said 3 words. "What did you do?" What neither of them realized was that 4 other pilots had been listening to Wright's radio calls during the interception. Word spread through the squadron in hours. By evening, 3 other pilots had asked their crew chiefs if Ridley could do the same modification to their aircraft. Squadron leader Peter Mitchell was a flight commander in 139 Squadron. He'd been flying Mosquitoes for 8 months, 27 operations, no losses. Mitchell was careful, methodical, exactly the kind of pilot who survived long tours. But he'd been listening when Wright called out the speeds during Ashford's interception. He'd heard Wright say they were holding 385 miles per hour. That was impossible. The Mosquito's maximum speed was 380, and that was in perfect conditions with light fuel load. Mitchell found Ridley in the maintenance section that evening. Ridley was working on a different aircraft, checking cylinder compression. His hands were black with engine oil. Mitchell asked him directly what he'd done to Ashford's aircraft. Ridley looked at him for a long moment, then told him everything. The mixture adjustment, the broken safety wire, the unauthorized modification, the calculations, the risks. Mitchell listened without interrupting. When Ridley finished, Mitchell asked if he could do the same modification to his aircraft. Ridley said yes, but Mitchell had to understand this could end both their careers. The modification wasn't approved, wasn't tested beyond one operational flight. If something went wrong, they'd both face court-martial. Mitchell said he didn't care. He'd lost 6 friends in the past 2 months, all killed because the Mosquito was 10 miles per hour too slow. If there was something that could close that gap, he wanted it. Regulations could wait until after the war. That night, Ridley modified Mitchell's Mosquito. Same process, same adjustment. 3 rotations on each carburettor. Mitchell flew it the next morning. came back raving about the performance. The aircraft felt like it had been holding back before, like someone had uncaged it. He told his wingman. The wingman told Ridley he wanted the modification too. By March the 20th, Ridley had modified 12 aircraft. Word spread through RAF Marham. Pilots started asking their crew chiefs if they'd heard about Ridley's adjustment. Some crew chiefs refused, said it was against regulations, too dangerous. Others were willing to try. Ridley showed them how. Break the safety wire carefully. Turn the mixture screw 3 full rotations counterclockwise. That's it. Takes 20 minutes per engine. Changes everything. The modifications spread from Marham to other Mosquito squadrons. A flight sergeant at RAF Horsham St Faith heard about it from a pilot who'd transferred from Marham. He tried it on 1 aircraft. The pilot came back from his next mission with a smile, said the aircraft was noticeably faster. The flight sergeant modified 4 more aircraft. Other ground crews started doing it too. By early April, maybe 50 Mosquitoes in Bomber Command had the modification. The engineering officers noticed something was different but couldn't identify what. Mixture checks during inspections showed normal readings because the crew chiefs learned to temporarily reset the screws before inspections and readjust them afterward. The pilots knew. The mechanics knew. Nobody told the officers. The loss rate started dropping. In February, Bomber Command lost 11 Mosquitoes to fighter interception. In March, it was 7. In April, it was 3. Something had changed. Then the Luftwaffe noticed. German fighter pilots first reported the change in late March. Combat reports from Jägerschwader 1 and 26 mentioned that British Mosquitoes were flying faster than previously observed. FW-190 pilots who had successfully intercepted Mosquitoes in February were now unable to close on them in March. The British aircraft were outrunning them at altitudes where the Focke-Wulf should have had superior performance. Major Josef Priller was a Luftwaffe ace with 96 confirmed kills. He'd been hunting Mosquitoes since 1942, knew their performance characteristics intimately. On April the 7th, 1943, Priller intercepted a Mosquito over the Ruhr at 19,000 feet. He dove from altitude, built speed, closed to 2,000 yards. The Mosquito accelerated. Priller pushed his FW-190A to maximum power. He knew exactly how fast a Mosquito could fly. He'd caught dozens of them, but this one was different. It pulled away, not dramatically but steadily. Priller watched his range indicator count upward. 2,200 yards, 2,400, 2,600. The Mosquito was faster than it should be. Other experienced Luftwaffe pilots reported similar encounters. The British were flying the same aircraft, using the same tactics. But the aircraft were performing better, marginally, but enough to matter. Enough that interceptions that should have succeeded were failing. German intelligence examined wreckage from downed Mosquitoes. Found no obvious modifications. The engines looked standard. The airframes looked standard. Nothing visible had changed. What they didn't know was that the change was hidden inside the carburettor. A simple adjustment screw turned 3 rotations counterclockwise. Even if they'd found it, they might not have understood its significance. By late April, the Luftwaffe's fighter units were losing aircraft to Mosquito bomber raids at rates they hadn't seen before. Not because the Mosquitoes were fighting back, they still carried no defensive armament, but because the German fighters couldn't catch them to shoot them down. The psychological impact was significant. Luftwaffe pilots who had grown confident in their ability to intercept RAF bombers were now watching those bombers escape. The Germans tried to adapt. Some units started positioning fighters at higher altitudes to gain more energy in the dive. But the Mosquitoes were flying higher too, and the modified engines gave them better high-altitude performance. Other units tried to use the Bf-109G, which had slightly better high-altitude performance than the FW-190. But even the 109G couldn't consistently catch the modified Mosquitoes. The fundamental problem for the Luftwaffe was that they were fighting an enemy they couldn't see. They knew something had changed, but they didn't know what, and they couldn't figure out how to counter it. The modification never became officially approved during the war. The Air Ministry learned about it in May 1943 when an engineering inspector at RAF Marham noticed broken safety wires during a routine inspection. He traced them to the carburettor adjustments, wrote a report, sent it up the chain of command. The report created chaos. On one hand, the modification clearly violated regulations. On the other hand, it was working. Squadrons using the modification had measurably lower loss rates. Aircrew were surviving. The question wasn't whether the modification helped. The question was whether to punish the mechanics who'd installed it or quietly authorize it after the fact. In June, Rolls-Royce sent engineers to Marham to evaluate the modification. They tested it extensively, measured power output, exhaust gas temperatures, cylinder head temperatures, ran full power endurance tests. Their conclusion was that the modification was safe if carefully implemented. The mixture adjustment produced approximately 85 additional horsepower per engine without exceeding thermal limits. It should have been part of the original specification. In July 1943, Rolls-Royce issued a technical bulletin authorizing ground crews to adjust mixture settings on Merlin XT44 engines within specified parameters. The bulletin was carefully worded to avoid admitting that the original settings had been suboptimal. It simply stated that field experience has shown that performance can be enhanced through careful mixture optimization. Ridley never received official recognition, no commendation, no medal, no mention in any official history. The Rolls-Royce Technical Bulletin didn't mention his name. The Air Ministry documents credited the mixture adjustment to ongoing engineering optimization efforts. Ashford survived the war. He flew 47 operations, completed his tour, returned to Sussex in 1945. He married, had 3 children, worked as a civil engineer for 35 years. Every year on March the 12th, he wrote a letter to Ridley, thanked him for the extra speed that had kept him alive. Ridley kept every letter in a box under his bed. Mitchell also survived. He completed his tour, stayed in the RAF after the war, retired as a group captain in 1959. He told the story of Ridley's modification to every engineering officer he supervised, made sure they understood that the best solutions often came from the ground crew who maintained the aircraft daily, not from engineers in offices hundreds of miles away. Ridley stayed in the RAF until 1946, returned to Manchester, went back to working on engines, opened a motorcycle repair shop in 1949, worked on BSAs and Nortons and Triumphs for 40 years, never talked much about the war. When people asked, he'd say he was a mechanic, fixed airplane engines, that's all. In 1987, a military historian researching Mosquito operations found references to unauthorized carburettor adjustments in maintenance logs from RAF Marham. The historian tracked down Ridley through RAF veteran associations. Ridley was 71 years old, still working part-time in his shop. The historian asked him about the modification. Ridley confirmed the story, said it wasn't anything special, just something that needed doing. The historian estimated that the modification may have saved between 60 and 90 RAF aircrew lives based on loss rate improvements in squadrons that used it. Ridley said he never counted. He just remembered the crews who came back. Ashford, Mitchell, the others. That was enough. Thomas Ridley died in 1998 at age 82. He was buried in Manchester Southern Cemetery. His obituary mentioned his service in the RAF as an aircraft mechanic. It did not mention the carburettor modification. Did not mention that he'd changed how British bombers flew. Did not mention that he'd broken regulations to save lives. His motorcycle shop in Manchester closed in 2003. But in the small office in the back, there's still a faded photograph on the wall, a young flight sergeant in coveralls standing next to a de Havilland Mosquito. The date written on the back is March 1943, RAF Marham. That's how innovation actually happens in war, not through official channels or engineering committees, through flight sergeants and mechanics who see problems, find solutions, and don't wait for permission to save lives, through broken safety wires and turned adjustment screws, and 23 minutes of unauthorized work that added 12 miles per hour and changed the equation between hunter and hunted. The Mosquito went on to become one of the most successful aircraft of the Second World War, fast enough to outrun most interceptors, versatile enough to serve as bomber, fighter, reconnaissance platform, and pathfinder. The official histories credit its success to innovative wooden construction and powerful Merlin engines. They rarely mention that those Merlin engines were running mixture settings that a flight sergeant adjusted in the dark without authorization because pilots were dying and regulations could wait. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. And we'd love to hear from you. Leave a comment below telling us where you're watching from. Our community spans continents and generations. From veterans to history enthusiasts, you're part of something special here. Thank you for watching, and thank you for keeping these stories alive.